All right, so good morning. This question is also from the topic of mechanics. Very good question to understand concepts of mechanics. So I will explain you how to attempt such questions. Mechanics is a very dreadful topic for a lot of students across the globe. And therefore, I thought, I should strengthen and increase the playlist of mechanics. You can go to my lectures of classical mechanics playlist and watch other videos also. And don't forget to subscribe to this channel because you will get quality content with great detailed explanation on the physics questions, theories, and the conceptual ideas. Let's read this question now. All right, so let's read this. I will increase the size of this picture. So it's a situation of a 50 kg boy who is climbing a vertical pole. So you might have seen some people climbing a coconut tree and sometimes a pole also. And at a constant speed, okay, he's not accelerating, he's maintaining the speed. If coefficient of friction between the palms, which is the palm, the hand as in, and the pole. Okay, so there is a coefficient of friction between them. So which means the guy who is climbing, the boy, is experiencing some frictional force. Then the normal reaction between him and the pole is how much? That's a question. Okay, you have to find the normal reaction between the pole and the boy. So how do we solve a mechanics question first, right? The first step is to be able to draw a simple diagram to explain the situation. So I will draw a simple diagram to explain you the situation. All right. So let's draw this diagram, and this is your pole. Okay, that's your pole, and say this is the boy, and the two hands of the boy which are being used to climb are these. Okay, so these are the two hands of the boy. Let's discuss now. The boy has a mass of how much? Let me just enlarge the question. Okay, so the boy's mass is 50 kgs. So this is your 50 kg boy, okay, and the weight is acting downwards. So this is your weight of 50 g, okay, newtons, okay, and the two hands, okay. I have drawn two hands, but for all practical purposes, assume a single point where the normal reaction is acting. So I will change this figure. Okay, I have shown two hands because I generally use two hands to climb, but for all practical purposes, let's say it's a single point where the normal reaction comes back to the man. All right. So now let's focus on the free body diagram, okay, which exhibits all the forces very nicely. Okay, so the palm is pressing against the pole, right? So this is your pole, and the normal reaction is coming back like this. Okay, so this is your weight. This is normal reaction, and the man is pushing the pole with some force, and the same force has to come to him. Now, what is interesting is the word constant velocity, right? What does it mean that the guy is able to maintain constant velocity? How do we use it? That means there is no external force, or the external forces are getting cancelled. Now let's look into this free body diagram. If I just draw this, what is the impression you get? The guy will be pushed back and will fall, right? And will go down because of the weight, his own weight. So the boy has its own weight, which will bring him down. But the reality is the normal reaction is there. There is a frictional force also, which I will draw using a different color so that you can distinguish between the forces. So this is the frictional force which is acting on the boy. So let me just draw it. Okay, so this is the frictional force, mu multiplied by n, right? So you can see the normal reaction is here, the frictional force is upward, and The man is climbing, the boy is climbing with a constant velocity. Constant velocity tells me that there are balanced forces. Okay, balanced forces. Okay, and which means in vertical direction, okay, if I see the vertical direction, what happens in the vertical direction is mu multiplied by n is equal to 50 into 10 newtons, right? So this is 50 kgs into 10. Mu is known to be 0.75 multiplied by n is equal to 500, and therefore the normal reaction is 500 divided by 3 by 4, which is 2000 divided by 3, which is around 666 point whatever. So let's see the choices, right? So the choice number 4 is correct choice. The answer is equal to 6.67 Newton. Okay. Just a quick revision. Constant velocity. Why will you have a constant velocity when you have forces acting on you? Because you are being subjected to balanced forces. And remember, the motion is vertical motion, and therefore the vertical forces will balance each other. So this is a norm. That was a normal reaction which you are supposed to find, and you know the force of friction, right, is given by mu n. So generally, you see a body lying on the surface of horizontal nature, and you have a normal reaction here, and then you have the the body presses the earth and the surface gives a normal reaction. If the body tends to move in this direction, the force of friction is here. So the force of friction and the normal reaction are perpendicular to each other, which is the case here also. The force of friction F is in this direction, normal is here. So this is the angle between them, which is 90 degrees. So I hope this is making sense to you. Please use first you collect all your concepts, balanced forces. If it is an unbalanced force, what happens? Acceleration, right? So F is equal to ma is correct. But here one F is getting cancelled by the other F, which means balanced forces. So another logic you need to develop while applying Newton's second law is it a situation of balanced force or is it a situation of unbalanced force? Decide that and then move forward on the question. Please don't forget to subscribe to this channel. Watch my playlist on classical mechanics. It's a foundation of your class 11th and 12th. And a lot of questions from mechanics come in all exams across the globe, which lead to a good college, admission. So thanks a lot again and see you soon.